draft science video. Response to comments and next step in the conversation. Not much participation, unfortunately, but you know, that's typical. So anyway, as usual, the naysayer or the nitpicker, whatever you would like to call them, showed up and did get 4 thumbs up, which is irritating. And I can't respond to this guy's comments. I don't know why that is. Why can I not respond to some people's comments when they leave comments? Does anybody know the answer to that question? I don't understand. Why can't I respond to his comment? I can respond to the comment above his. See, there's the reply there, but no reply there. So why is that? I don't like it. And so if this guy, if that's some feature you can do to your comments, and so this guy did that on purpose, it's irritating. And I don't like it. Anyway, you do not have to move something even close to the speed of sound in order to create a pressure wave or sound. Well, that's what you say. And I think I'm going to prove you wrong. So, says you. It's about frequency, not actual speed. No, it's about the speed of sound. Yeah. And the fact is that any frequency can be carried on a sound wave. Yeah. The sound has to come first. The frequency on it, who cares? It's like a radio wave. You gotta create the medium before you can create the passenger kind of idea. Anyway, say I want to make a 10 kilohertz tone, which is quite high-pitched tone. I'd have to vibrate something like a speaker diaphragm at 10,000 times a second. This doesn't necessarily say anything about the speed of said diaphragm. Yes, it does. The fact that it's a speaker diaphragm is the giveaway here. Alright, so your calculations are based on you not really understanding what a diaphragm is. So we're back at that word tension again. And the necessity to propagate waves that you need to go from tension to tension to tension. You have to have, if you're going to communicate sound, or a wave, you're going to have to do it through mediums that create tension, that have tension in them. Alright. This doesn't necessarily say anything about the speed of said diaphragm. Well, yes, it does. I can make it vibrate at 10 kilohertz at an amplitude of a couple of millimeters or centimeters. All this does is change the loudness of the tone. No, it just changes amplitude. It's changing how much, how many waves you're creating, how much atoms, how many atoms you're moving. So the more atoms you move, just like photons produced by other light signals or something, it's about the number. The number of photons is the amplitude of a light. And with waves, it's the number of initiated sonic booms, pressure instigations. Okay, instigations in an atom, where an atom is moved faster than the speed of light, and a vibration is now perpetuated through that process. So amplitude is about how much mass you move to create your sound. Let's see. This doesn't necessarily say anything about the speed of the diaphragm. It can vibrate. Does not change the loudness. Okay. If my diaphragm vibrates at 10,000 kilohertz, 10 kilohertz, with an amplitude of 2 millimeters, it moves about 2 millimeters 10,000 times a second. That is just 20 millimeters a second, or 45 miles per hour. Alright, so what you've done here is, number one, you should have caught yourself and said, oh, wait a minute, this doesn't make any sense to do this math this way, because then I'd have to argue that if it was a 40 kilohertz signal, I would end up going 440 miles an hour. And that's not what you did here, right? So if it was an 80 kilohertz, then it would be going 800 and something miles an hour. It'd be going faster than the speed of sound. So this doesn't do any good in terms of indicating the perpetuator, the thing instigating the vibration. And so what you're missing is that word tension. So a speaker diaphragm, I guess I might as well start drawing. Take the lid off this. So there's a couple of concepts I'm going to go through. Just so I want to restate a couple of points. So what I'm thinking about is the tension is the key to this whole thing. So when you have a speaker, you know, what's basically happening is, number one, the speaker is designed to be at tension. So the speaker paper or cloth is at tension in the way it's designed. And then there's a magnet here that merely pulls the diaphragm down. So it pulls the speaker down every time there's a signal. There's a little rod here, a little metal rod going. It's a solenoid essentially, and it just pulls this rod in and out. And that, by doing that, creates these vibrations of when the speaker vibrates. But what's really happening is when the signal goes into this coil. This is a coil, and you know, the electrical signal is just sent to the coil. What's really happening is it's just pulling it one way. It's just going down. That's the only part that means anything to the speaker. And it's the release points. So it pulls it down, and when this springs back is when the noise is created. It's the springing back, it's the tension in the speaker that creates the sound. So you can't measure how many times it's possible for you to pull this down. The real speed is in the rebound speed, and the rebound speed of the speaker paper that's where it ends up going faster than the speed of sound, especially if you consider that the speaker, the fabric that the speaker might be made out of, might actually have little hairs on it, and those little hairs waggle. You know, so as this diaphragm moves, the hairs spring, and so it might even be just the hairs on the speaker fabric that are actually creating the sonic booms. They're doing the whipping. But I can't say for sure. I'm just saying it, but it probably has something to do with that, because tensions, textured papers do seem to make it better. Well, they do use plastic speakers, but those are kind of those are really high tension, and they're very good at higher frequencies, obviously, for that reason. So what do I want to say? Okay, so it's rebounds. It's the rebound speed. Okay, so you tell me what the rebound speed is of a speaker, and then we can talk. You know, about how fast it is. It really has nothing to do with the frequency. It has to do with the fact that frequency is just, you know, again, frequency is about how often something happens. Like it happens now, and then it happens there, it happens there. This is the frequency, okay? Is how often something happens. The space in between is frequency. The space in between events is frequency. Okay, not the speed of the event. So when a speaker moves, it rebounds probably at the same speed all the time. Who knows what it is, but it's fast. And frequency is just how many times it moves. So, you know, it can move. You could have frequencies that are very wide, or frequencies that are very tight. And all of these movements would be the same speed in terms of, to get to the amplitude point, to get to the high points, would all be the same speed of initiation, you know, where the wave is created, where the peak is created. Those happen. This part of the wave happens, okay, this part here happens at the same speed. It's technically, like I said, could be that it's the rebound that you're really hearing, so it's really the other side to the wee woo. It's the second half that's making the noise, but it doesn't really matter. The point is that frequency says nothing about how fast the amplitude was created. It says how often the amplitude is created. Big difference. So, you four people, I expect some sort of acknowledgement that I have answered this comment, and that you were booger heads for rating this comment up when this comment was fallacious for two reasons. First, it didn't take into account the fact that speakers make the noise on the rebound, And second, it had this obvious flaw where you could obviously figure out that frequency has nothing to do with the speed of the wave. That's determined by the speed of sound. Frequency only has to do with how often the wave is initiated. And it is reinitiated. So that's another point here. So I was going to get to that. I mean, I did this simple little drawing. But because frequency is very much, I think, just the stuff between incidences. It's the nothing. So frequency is an acknowledgement of a nothing. So if you could theoretically argue that all photons were alike. So from radio waves to cosmic rays, all these photons are alike, and light would be somewhere around here, and ultraviolet would be here, and infrared over here, and all these photons are the same. And what's really happening is just the distance between photons is what you're counting as the frequency. So for radio, the distance between photons is large. For cosmic rays, the distance between photons is short. So it's how often there is a disruption that affects something. So I would almost argue that it might be that a photon technically isn't really a one thing. A photon is a two thing. Photons are a pair of quanta, let's say. And so it's just the distance between two associated quanta. And we call that a photon. But what it really is two ends with a space in between. And it is the space that determines frequency. It is the space between the two things that is creating the wavelength, in theory. And I like that. I think it's perfectly swell as a way of looking at things. And so yeah, but that goes back to the atoms. And so again, it's the atoms, they're associated with each other in the atmosphere. And although the atmosphere doesn't seem like it's under tension, it is in fact under tension. The atoms are directly associated with each other. And if one gets instigated by a amplitude moving at the speed of sound, it will instigate its neighbor with that instigation. The instigation will travel through it frictionlessly, theoretically, with very little friction. And that's the key to tension. Tension is a way of negating losses to friction and other things. But tension also creates more energy. So you can, it's that idea of pulling back the spring and then releasing it. You're building up potential energy as you compress the spring. You're applying kinetic energy slowly and then releasing kinetic energy quickly. So there's more energy in a system than you might think there is, based on what went in. So it's like when you pull the rubber band, a stretched rubber band or a guitar string, it's now under tension, and so there's a lot more force when you pull or pluck. You're applying a lot more force into it, and a lot more energy, and then the creation of its rebound is where the sonic event takes place. Alright, I was initiated. So the other thing I was thinking of was electrons. We're back to them again, so I guess I did tension, so yeah. So electrons, I was thinking of revising the last video's statements about movement. I was talking about the center of gravity and the fact, that there's something gyroscopic happening inside the atoms. And that's why there's no orientation difference. Once that has movement in a direction, it has movement in that direction. It doesn't matter how you reorient the object, the mass is still moving in that direction. And I talked about the fact that I think the problem is that it's a reorganization of the mass, and for movement to take place, for something to move from here to here. What's really taking place is a net difference in the speed of light photons that are captured inside of it move in their orbits directionally a little more in this direction. You know, the frame rates here are so different that there's no way to make that visually understandable, because you're talking about like something that's happening on an event scale of zillion to 1, and here you are at 1:1 resolution, so it's going to be really hard to see that frame rate. Alright, but anyway, the way I've re-understood it is, you know, instead of, I think it still has something to do with the atoms and the idea of the atom having a center of gravity, a nucleus, and then the orbit, and how centric that is would make a difference. But I think more importantly is back to this, I'm really liking this double helix idea for electrons being created out of photons, and that the photons in this configuration, when they're spinning, how fast they spin regulates how fast the electron moves. And so what you could argue is when something's moving in a direction, or when it's initiated to move in a direction, what happens is some portion of the spin of the electron is lost to compensate for the direction. So if something's moving in this direction and the orbit, let's say, was in that direction, my argument is there's a point where the photon inside the matter would be going in the direction of the movement, and there would be this problem of going faster than the speed of light. So to compensate for that with this double helix thing, what would all that would be happening is that the spin of the electron would slow down when this took place. So at any point where a photon was moving in the same direction of the direction of movement, there would be a decrease in spin of the electron. And likewise, a compensating increase in spin when it was going in the opposite direction of the movement. And so in that way it could remain balanced to a movement and yet gain a momentum change. Now, how the momentum is maintained has something to do with this vibration thing. So now we're back to vibration and tension. So what I'm going to argue is that if something moves, tension, it's a tension that's created with well, it's got to be relative to something. You know, the movement's always relative to where everything else is. You move basically relative to the Earth and the other planets in the solar system, or whatever the other references are. And so you're moving relative to the tension they create between you and them to one aspect. That would be one aspect where you could essentially negate the existence of, negate's the wrong word, diminish the significance of the space between very distant objects. And so this might explain why the universe appears so big. It might not be as big, because the fact is that their space doesn't really exist. What exists is the space that's in tension. And space that doesn't have any tension doesn't really exist, but it still appears as distance. Well, I don't even want to get into that. The important thing at this point is that I think the spin of the electron is important in dampening the effects of movement, or at least acceleration. And what maintains momentum, though, we still have this idea that momentum is somehow captured in the thing moving. The thing inside, it's in there. Something outside isn't telling it to keep moving. Something inside of it tells it to keep moving. And yeah, I have to do a little more work on that. But I think that has to do with the center of its gravity and the fact that it's essentially creating a because of its orientation of its interior bits, it's creating a kind of gravity that's forward to its movement. So it's essentially creating gravity. So when something's moving, there's an artificial gravity created in the direction of its movement. And it's not really technically artificial. What you can argue is it's the same force that planets create or other material bodies create that influence things, and that somehow this movement was, it's the same force. The momentum is the same force as gravity. It's just that they're created, they're initiated inside the thing through a different mechanism. So why we think of gravity working us down constantly, all it's done is changed our configuration. We don't see the gravity, we just see the effects of it on us. So we assume there's some sort of force pulling down on us because that's what it seems like it is doing. But it's really us just acquiring a momentum without a force that pushed it down on us. So instead of a rocket engine pushing us and making us move, we're moving because something has changed our interior structure. And the reason why something moves because a rocket engine's pushing it, okay, is because a vibration change has happened. The same kind of change has taken place to the material through acceleration. So through acceleration, it acquires momentum, and the process of acceleration did this stuff to the electrons. It reduces the number of the amount of spin of the electrons, and so as it accelerates, the spin of the electrons is changed, and it is that change that creates this illusionary, this gravity, this fake gravity that sits in front of the direction of momentum. So the two forces are the same, I would argue. Their effects are identical. Once initiated, once you're in a gravity field, you've been infected with gravity. You're not getting out of it unless you accelerate out of it. You have to move out of it. You have to put an opposite force to get you out of it. So in that sense, it's this very same thing as me initiating acceleration and pushing something in a direction. It's essentially the same thing as putting an artificial gravitational body in front of it and moving that and just pulling it on like a magnet. And that's essentially what's kind of happening. There's the force, I guess I'm contending the force that's not real is gravity. The one that, if we understand how momentum is maintained through the interior configuration of an object, then that's how it's maintained. The object keeps moving. There's nothing making it keep moving. It keeps moving. It has to keep moving. It's doing it. It's moving. Something else isn't moving it. It's moving once it's accelerated. And that's what's happened to us here. Being in gravity is that all we've been is put into the moving space, and we can't escape that unless we apply an opposite force. And it just happens to be that we can't apply the opposite force somewhere else. We have to do it while we're still here in the Earth's gravity. But if the Earth stopped existing right now, if the Earth just disappeared, I think, okay, we'd still keep moving towards the Earth. We'd want to go with it. We'd still be moving down. We'd still be heading for the center of the Earth. And if the Earth was gone, we'd just shoot right through the center and keep going. Yeah, interesting. Anyway, so more to come and such. And I mean, I'm gonna say fuck you, but I mean, it's just rude. You could say something like, wait a minute, Gary, what about this? I think this might be something here you didn't consider. That would be polite. but to talk as if you know something, and that this crap, and it's crap, is a repudiation of my theory, is crap. So, fuck you. Do it more politely, please. And certainly do it better. See, if I had my editorial system here, you'd lose points for this. So you'd lose a little bit of credibility when you do this. Because I demonstrate you to be pretty much wrong. Just like Warbles on a lot getting 33 miles to 33% improved gas mileage with his solar panel. I'd prove you to be full of crap, and then you'd get a few points off because, yeah, you blew it. You challenged and you failed. And you should wear a little badge for that until you're right a few times in a row. Being wrong should count for something. And